Good morning. In this class, we are going to discuss about the locations of various sections. In my last class, we discussed about these locations, and we have got two methods. One is method of summation. Here are the formulas, and the other method is method of integration. Okay, and these are the formulas: integration of x dA divided by integration of dA, and this is the formula for y bar. Now in this video we are going to see about a method of integration. For that I have chosen two lamina, one is a rectangular and another one is a quadratic circle. First let me take the case of a rectangular lamina. Again I am going to use the same I am going to use the method of integration. So here are the formulas: x bar equal to integration of x dA divided by dA for finding the value of x bar. Similarly y bar has the formula this one. Okay, now if you look at this formula, it has some variables or some parameters x and dA. Now we are going to see this in detail, and this is the rectangular having the height h and width b. Since I need two parameters dA and x, first let me explain you about the term dA. So dA is a small elemental area. Okay, here you see that this is the elemental area. Moreover, I have taken this one parallel to y axis. Reason is I am going to find the value for x bar. X bar is the distance between the y axis and the centroid. So this elemental area should be parallel to y axis. Then the side of this small elemental area is h on one side and dx on other side, because this dx is lying on x axis. So here I have taken this as dx. Now dA equal to h into dx, because it is a rectangle. So here h is one side and dx is other side. So dA is equal to h into dx. Then you have to know one thing: this is the dA. It varies from 0 to the other end b. Here this is the lower limit and this is the upper limit. Lower limit is the origin, okay, 0. Upper limit is the maximum value of this width. Maximum value of this width is b. So here the dx varies from 0 to b. This you have to understand. Next one, x. It is again a variable, and here this dA is located at a distance of x from the y axis. Now use this equation. First take this numerator. I have taken the numerator, which is equal to, now as I told earlier, this dx varies from lower limit 0 to upper limit, the maximum value of width, it is nothing but b. So 0 to b. Then x is a variable that I have already told to you, and then dA, in the place of dA you just substitute this one h dx. Now x dot h dot dx, and if you look at this one among these three, x, h and dx, h is a constant, so it can be taken out. So constant is taken out. So the remaining thing is integration of 0 to b x dx. When you integrate this one, you will get the answer as x square by 2 having the limit of 0 to b, and in the place of x I substitute the limits. Here the upper limit is b, so hb square by 2. So this is what we arrived. When you substitute the lower limit, this time will become 0. So I have neglected, and this is the answer for the numerator. Integration of x dA will has the answer of hb square by 2. Next I am going to take this denominator, integration of dA, and again integration of dA, which is equal to 0 to b. dA can be replaced by h dx. Here the constant h is taken out, and 0 to b and dx. Here the dx again, it is a limit, it varies from 0 to b. So since the integration of dx will give the answer as x, has the upper limit of b and lower limit of 0. Substitute the upper limit, you will get the answer of hb. When you substitute the lower limit, this time will become 0. So integration of dA will have the answer of hb. Now if you substitute both numerator and the denominator in the above equation, you will get the equation is something like this: hb square by 2 into 1 by hb. When you cancel h and b's and b square, so finally you will arrive the equation of b by 2. Similarly, y bar can also be found as like the same procedure. Finally you will get the answer as h by 2. But when you can work out on y bar, the elemental area should be parallel to x-axis, because y bar is referred from x-axis only. So dA should be parallel to x-axis, and then the limits varies from 0 to h. So this is the only difference. So finally you will arrive the equation of h by 2. So this is the centroid for a rectangular lamina. In the same method, I am going to find the centroid for a quadratic circle, and I'm going to use the same equation: x bar equal to integration of x dA divided by integration of dA. Here this is the rectangular, this is the quadratic circle. Okay, so this is the quadratic circle having the radius r, and one end of the quadratic circle is on x-axis, the other end is on the y-axis. Now if you use this equation, here there are two variables again, x dA, where dA is a small elemental area. I am going to consider a small elemental area like this. Here it is taken as dA. Moreover, this is the centroid G, and this is y bar, this is x bar. We are going to find this value only, x bar and y bar only. Now the small elemental area is located from x-axis at a distance of theta, where theta is a variable. It varies from 0 to 90 degree, and this is the d theta. So now I can enlarge that one little bit higher than, so you can easily view this one, and this is the enlarged view of that small elemental area. Here this is the centroid for the elemental area, and the elemental area has one side of r. This is equal to this one, because this is the radius and you have the same radius here also. So this is r, and other side has the value of r into d theta, where d theta is this one. So this is r d theta. Now to find the dA, I am going to consider this small elemental area as a triangle. So of BH, of B in the place of so r is going to be placed here. This one is h one is r d theta. So this is the formula, and again one more variable is also there, x. Here now to get that value of x, this is the position of centroid from this point end, and this length is taken as r, and r, since it is a triangle, it can be taken as 2 by 3 of r, something similar to triangle. I am going to use the same triangle formula. So 2 by 3 of b, but here b is nothing but r, so 2 by 3 of r. But if you look at the case, here the variable is x, but here the variable is in the form of r, so it has to be converted into x. For that I am going to take a right angle triangle. So this is the right angle triangle, this is the theta, this one theta, and this one is a hypotenuse for that right angle triangle. This is adjacent side x, this is opposite side y. Now x, I need x only, so I am going for trigonometric relationship, that is cos theta equal to x by r. Okay, from that relationship I got the answer of x equal to 2 by 3 of r into cos theta. Now come to this equation. So this is the equation, integration of x dA. Now you need limit also. Again, as I told earlier, this theta varies from 0 to 90 degree, but we have to use radian relationship, not the degree. So 0 to by 2, by 2. So this is the variation of this angle theta. Now let me take the denominator first, integration of dA, 0 to by 2. This is the variation of theta, and dA already we got the answer of BH of r into r d theta. Just substitute over here, and now you just take the constants out. So 1 by 2 r into r, so this constant, so finally these three are the constants, so it can be taken out. R square by 2 integration 0 to by 2 d theta will be there, and integration of d theta is theta, and you just substitute the upper limit by 2, lower limit will be 0. So you will have the relationship something like this, r square by 2 into by 2, which is equal to by r square by 4. So the denominator has the answer of by r square by 4. Next I am going to take the numerator. Okay, numerator x already we have found 2 by 3 r cos theta, substitute over here, and then this is the d theta, already we found out that is r square by 2 d theta. Now just cancel 2 and 2, then r by 3 r square, this constant can be taken out, so r cube by 3 integration 0 to by 2 cos theta into d theta. Now integration of cos theta is a sin theta and has the limit of 0 to by 2, and substitute the upper limit sin by 2 and sin 0 is the lower limit, but this will be 0. Okay, this will be 1. So r cube by 3 as the answer. Okay, now substitute into the above equation, r cube by 3 into 4 by r square, and you know that you can cancel the terms and you will get the final answer as 4r by 3 pi. So this is the answer for the centroid x bar. In the similar manner, use the same approach, you can get the answer for y bar also, which is also 4r by 3 pi. Using method of integration, we have found the answer for two laminas. One is a rectangle, has this answer, and second one is a quadratic circle, has this answer. Okay, both x bar and y bar has the same answer, 4r by 3 pi. In the similar manner, we can find the centroid for any lamina, any plane lamina, and we have done and we have got the answers for some of the lamina that we are going to see now. First one is a square lamina, has the side of A, and this is the point G, and the x bar value is A by 2, y bar value is again A by 2, and this is the area A square. Second one is a rectangle, already we worked out. Here the width is taken as B and this height is taken as D. Now this is the x bar, this is the y bar, has the answer of B by 2, D by 2, and this is the area B into D. Then the third lamina is a triangle, a right angle triangle. You see here that the axis is very important. Okay, this is the x axis and this is the y axis. The one side has the width of the triangle is B, the height of the triangle is H. This is x bar. X bar is equal to B by 3 and y bar is equal to H by 3. In some cases, if it is referred from this end, then this height will be 2 into B by 3. Okay, so if the axis goes along this point end, then here you have to note that the answer is 2B by 3. So this is from line end. You see here, this is line and this is x bar. Suppose if the y axis passes over through this end, then it will be 2B by 3. Similarly here also, if it is referred from line end, it is H by 3. If it is referred from point end, it is 2B by 3. And again the same formula of BH. And the fourth one is a circle of radius r having the centroid over here, and this is the axis. X bar equal to again r and y bar is equal to r, area is by r square. Then the fifth one is a semicircle of radius r. This is the y-axis, this is the x-axis, and x bar equal to, you know that this is y-axis, this is the point G, so this is the radius. So directly you can put the radius as the answer. But from this diameter end to this point G, y bar, and now the y bar is equal to 4r by 3 pi, and the area is by r square by 2. Okay, here this is very, very important thing. And similarly the last one is quadratic circle. Already we arrived the answer. This is the position of centroid. X bar now equal to 4r by 3 pi, and y bar is equal to 4r by 3 pi. Similarly the area is equal to by square r by 4. Okay. Thank you friends, we will meet in the next video.